Math 2, 10.4. Today we're going to talk about multiplying and adding rational expressions. Okay, when you are multiplying radicals, do you see how both of these numbers are under the radical? Now, while you can multiply them together, and sometimes multiplying them together is better, you don't have to multiply them together. What I mean is that I'm going to take a root, and anything that's under the root gets multiplied under the root together. But I oftentimes will just write this as 2 times 8, because I'm going to end up doing the factor tree, breaking it down anyways. If you had numbers outside of the roots, you would multiply those together as well. So outsides multiply with outsides, insides with insides. Okay, now we know 8 breaks down to what?
2, 2.
Very good. 2, 2, and 2. So I have one group of 2's and another group of 2's. So this answer is 2 times 2, which is 4. Because I have two groups of 2. This makes a 2, and this makes a 2. Also notice this doesn't have a number for the root, which means that it's a 2. Otherwise, they would tell us, like a 3 or a 4 or whatever. Right? Okay, so on number 2. Oh, is this rational or irrational?
Rational.
Okay, I just want to make sure you know. Okay, number 2. So again, I have two roots. We're going to multiply them together. I'm just going to write this as 3 times 6. Can either one of those numbers break down?
Yes.
What?
2 times 3.
Good. 6 is 3 times 2 or 2 times 3, but that gives me a pair of 3's with a 2 left over. How do I end up writing that answer?
3 root 2.
Very good. 3 root 2. Is that rational or irrational? Very good. Irrational is correct. Okay, so on number 3, I'm going to write this out so that you see what's happening in case you have to look back at your notes. We have 3 times 2 on the outside because of this 3 and this 2 on the outside. And then under the root, I have 5 times 10. So, can either of those numbers under the root break down? 10 breaks down to 5 and 2. So I have a pair of 5's, or a group of 5's, and a 2 left over. Now, outside the root, we have 3 times 2, which we're multiplying together, and that makes, I'm just going to write that as a 6. When I bring the 5's out, we multiply that with the 6, and so 6 times 5 makes 30 root 2. Rational or irrational? Very good. Okay, on number 4, I would just multiply these numbers when I'm writing it out. So 4 times 2 ends up making 8 root, and then what do I write underneath? 6 times 12. And 12 breaks down to? Good. And there's 3 and 4 as well, but I'd use 6 and 2. And why am I using 6 and 2? Because then it can make me a group. Very good. So I have a group of 6's and a 2 left over. So I could have broken down 6 to 2 and 3 and the other 6 to 2 and 3 and this and that, but I would still end up with like a pair of 2's and a pair of 3's, which makes 6. So anytime you have a group, you don't have to break it down any further. It's kind of like a shortcut. As soon as you have a group, circle it, you're done with it. Okay? So when I bring this out, what is it going to become?
48 root 2.
Very good. 48 root 2 is correct. Bless you. Okay. So now we're moving on to when we have variables. And I work with these a little bit differently. Okay? So I start with both of these under roots. They're being multiplied together. So I'm going to make my root, and I'm going to go 2 times 12. So I'm going to put all of my numbers together. Okay? And then I put all of my letters together. How many letters are there? It's going to be x to what power? I would write that as x to the 4th. Okay? From there, I'm going to break things down. So what should I break 12 down to be? 2 and 6. Okay? I see that I have a pair of 2's. Should I break 6 down any further? Will that give me any pairs?
No.
No. So since it's not going to help me out, I'm just going to box it and be done with it. Now we go to the x's. How many do I need for a group? 2, right? And so how would I end up writing this? Good. X squared. And there's nothing left over with the x's. So how do I end up writing this answer?
2x squared root 6.
Perfect. Very nicely done. 2x squared root 6 is correct and it is irrational. Okay, you guys want to try 6 on your own? Yes, I think that sounds great. You should try it on your own.
Okay.
Let's see if you can do better than the last one you did on your own. Okay. The answer should be 6x to the 4th root x.
Wait, what was it?
Did you guys try 7 or 6?
6.
Okay.
Right?
All right, let's see what happens.
Wait, what was this supposed to be?
6x to the 4th root x.
Yeah.
6x to the 4, 4x.
Did you get it? 3 times 4 is 12, yes. And 4 breaks down to? Okay. All right, here we go. So we have the square root. 12 times 3. And then I have x to what power?
Third.
Plus?
Oh,
Good. X to the 9th. Is everybody so far okay with this?
yeah.
Now, I heard some of you say that 12 breaks down to 4 times 3, and you have a pair of 3s, which is true. But can 4 break down to a pair?
Yes.
2 and 2. No numbers left over. Okay, now moving on to the x's. We're going to go in groups of 2. So we have 2, 4, 6, 8, 1 left over. I did do 3 and 4. So 12 was 3 and 4, group of 3s. But then 4 is 2 and 2. Does that make sense? Okay, so when I pull out the group of 2s and the group of 3s, what does that make? 6. And then how many groups of x's? 4. So that's x to the 4th. Root, what's left over? X. So that is my answer. Okay. Do you guys think you need to redeem yourselves by doing number 7?
Yeah.
Sure.
Okay, let's see what you can do. In fact, I think the first 3 to get it right get candy today. Okay, 1, 2, 3. You're 4, you're 5. I'm going to come and check them. Okay. But I'll just be fair. Hold on. 1, you were 2. No, you don't have 2 roots in one stack. Very simplified to just have 1. Okay, who was my 3rd? Super close. This should be, is that 5 or 6? Your y's are up, and under your root, you should have a y as well. Yes, you got it. 4, 4. That's it. You got it.
Wait, let me see if I got it right.
4 feet by 4 feet. Yeah. What are you talking about?
Wait. Can you just check one? Do you mean a double double?
Yeah.
Yes.
4 by 4.
Got it in? What is it? Yes. You're lying.
No.
Yeah. You didn't know that?
No. Is
You can
it?
get like a 4 by 4, 5 by 5.
X's are wrong.
Yeah, you could get like
Hold on a second.
I think it's a little bit.
You are missing something. I usually got it. Okay. I'm sorry. Okay, for time's sake. The answer is 4x squared, y to the 5th, root 2xy.
I got like half of that.
Okay. And I Okay. All right, so let's go through this real quick. I would start by writing this out as 8 times 4. I have just x to the 5th, and then I'm going to have y to what power?
11.
Very good. Now, what would I break 8 down to?
2, 2, and 2.
I could do 2, 2, and 2, which is totally fine. But since I have a 4 here, I'm actually going to do this to 2 times 4 because then I have a pair of 4s and a 2 left over. Now, if you did it a different way, that is also good. Okay? Now, x to the 5th, how am I going to break that down?
X squared, X squared, X.
Good. So, group, x left over. Y to the 11th. 2, 4, 6, 8, 10. 1 left over makes 11. 1, 2, 3, 4, 5 groups. 1 left over. Okay, so how do I write that answer? Looking at my groups, I'm going to write those first. I have a 4, x to the 2nd, y to the 5th, root. Now I'm going to go look from my boxes. 2, x, y. Those of you I noticed that are not using boxes are missing the stuff you put inside. If you box them, you will visually see, oh my gosh, that goes back inside. When you don't do the box, it's easy to miss it. Okay, so I would encourage you to do your like circles and boxes. Okay, moving on now to adding and subtracting with radicals. You need to treat radicals like variables. So when adding and subtracting, you can only add the coefficients. Coefficients are numbers in front. If the radicals are exactly the same. Now, on number 8, do you see how both the radicals are root 7? Okay, if you could simplify them or break 7 down and pull out pairs, you would do that. Okay, in this case we can't. What number is in front of this radical if it's not there?
1.
A 1. So since these are both root 7s, we can end up adding those together, and that makes 1 plus 4 is 5 root 7. And that can't be simplified any further. Example 9. These both have root 3s. Therefore, we can go 8 minus 3, which is 5 root 3. And that can't be simplified any further. Okay, number 10. Both of these are root 13s. So we can add the numbers in front. 8 plus 7 is 15. Root 13. Good. Okay. What do you notice about these radicals? They're different. Sometimes you can simplify one of the radicals and it will make both of the roots the same. Sometimes they won't be the same. The only time you can add them is if they're the same. Right now, I cannot add these together. But could I simplify either one of those? Which one can be simplified or changed? What does 12 break down to? 4 and 3, and then 4 breaks down to 2 and 2. Again, I have a pair of 2s, a 3 left over. Make your circles and boxes. How do I write this answer? 2 root 3. This one can't be simplified. I have 4 root 3. Are the roots the same now?
Yeah.
Yes. So what is my answer? Very good. Okay, let's go ahead and do 12 together. Right now, are these roots the same? No. So we need to break them down. What should I break down 18 to be? 9 and 2. And then 9 is? So I have a pair of 3s, 2 left over. What am I going to do with x to the third? X squared and then x left over. So 1 group, 1 left over. Okay, so when I write this answer, pay attention because there's an x in front. So you start with your numbers. So it's going to be what? 3, and then it's going to be x what? X squared is correct because you have 1x, right? And then you have 1 group.
Oh, yeah.
So that 1 group just makes an x. So we get x squared. And then what's going to be underneath the root?
2x.
Just 2x. Good. Because I can see with my boxes, I have a 2 and an x. Okay, I'm going to do a different color on this other one so we can keep them separate. What would I break 32 down to be?
8 and 4.
Okay, if we do 8 and 4, that works. But instead of making 8, 2, 2, and 2, what would be easier and less work?
4 and 2.
Good, 4 and 2. Because then I can see I have a pair of 4s and a 2 left over. If you broke those into groups of 2, that's fine. You just end up with 2 groups of 2s, which will still become a 4 when you bring it out to the front. Okay, x to the 5th, how am I going to write that? X squared, and x. Good. 1 group, 2 groups, 1 left over. So when I write this one, what does it become?
24.
Wait. Good, because we have this 6 outside. Good job. 6 times 4 is 24. And then, good. Root 2x. Okay, so we did 6 times 4 because there was a 6 outside. I had a group of 4s. I had 2 groups of x's, so that makes x squared. And inside, those were both of my box terms. Those stay inside. Okay, so now we can add those up, and I get what? Yep, so you just keep the x squared, just like you keep the root, and then you have root 2x. So you're just combining the numbers. Okay, 13, I'm going to give you 30 seconds to do it on your own. Yeah, kind of can you show me your answers kind of on your fingers? One number is the number in front, one number is the number under the root. There you go. No. Okay, that kind of works. Unless you're saying it's separate there. No. Okay, can you break 8 down, you guys? Can you pull out a pair there? Some of you need to simplify further. Look, see if you can simplify further. Okay, what did you break 32 down to be? Okay, if you do 8 and 4, okay, and then we know 4 breaks down to what?
2.
Or 2 and 4. Pair of 4s, 2 left over. So within your square root, you always want to break it down as far as you can. Because some of you maybe wrote 2 root 8. Is that correct? So, but 8 you can break down. And so how do I write this as? 4 root 2. Okay, 8 breaks down 2, and on this one, I would go ahead and do 2, 2, and 2. So I have a pair of 2s, a 2 left over. So how do I write that one? 2 root 2. You're being super loud. Okay, 4 minus 2 is 2 root 2. If you got 1 root 8, which I think some of you did, do you guys understand how that's okay, but 8 still breaks down to 2, 2, and 2? You'd have a pair of 2's and a 2 left over, so that still gives you the answer of 2 root 2. You have to simplify under the root. So if it can be broken down, you need to. Is that clear?
C.
Questions?
No.